Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry questions. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, I have in the diagram below, triangle ABC is a right angle triangle with the line CB perpendicular to the line AB. Triangle ABC has vertices A35, B1217, and CX20 in the Cartesian plane. 1. Determine the gradient of AB. 2. Ends. Write down the gradient of BC. 3. Now determine the value of X. And 4. If the line BC equals to 5 units, calculate the perimeter of triangle ABC. We have to leave the answer in the simplest short form. Starting with the first part of the question, to determine the gradient of the line AB, we have 1. The gradient of the line M of AB is equals to the change in Y over the change in X values. Our A, we have that as 3,5. I'm going to tag that as our A is 3,5, and my point B is 12,17. Tagging my point, I have this as x1, y1, x2, and y2. And slotting in the values, y2, I have that as 17 minus y1, 5, divided by 12 minus 3. 17 minus 5, that's 12, over 12 minus 3, 9. Reducing, dividing by 3, I have that as 3. 9 divided by 3, I'm going to correct that. 12 divided by 3 will give me 4. And 9 divided by 3 will give me 3. So therefore, the gradient of the line AB is equal to 4 over 3. The second part of the question says, write down the gradients of the line BC. If I go back to the diagram, I have line AB as shown, and I have the line BC. You can see that they form a right angle. So the gradient of the line AB multiplied by the gradient of the line BC will give us -1, because the gradient of two lines that are perpendicular when multiplied together will give you -1. From the first part of the question, we found the gradient of line AB to be 4 over 3 times the gradient of line MBC equals to -1. Therefore, taking now 4 over 3 to the other side, I'm going to have the gradient of the line BC to be equal to -3 over 4. The next question says we are to determine the value of X. So I have question 3. To find X, note that from the previous question, we found the gradient of BC to be equal to -3 over 4. And the gradient of the line is your change in Y over change in X. I'm going to correct that. I have my X2 minus my X1. The coordinates of B is 12 and 17, and the coordinate of C is X and 20. If I tag that, I have that as X1, Y1, X2, Y2. So putting in the parameters, I have -3 over 4 is equal to Y2, that's 20, minus Y1, 17 over X2, X, minus X1, 12. From here, I have that as 20 minus 17, that's 3 over X minus 12. If I cross multiply, what I will have is cross multiplication means my negative 3 multiplying x minus 1 and 4 multiplying 3. What I'll be left with is I have negative 3 multiplying x minus 12 is equal to 4 times 3. If I simplify by dividing both sides by negative 3, that's equal to 12. 4 times 3 is 12. I'm left with x minus 12 equals 12 divided by negative 3, that's negative 4. Therefore, my x is equal to negative 4. I'm moving my negative 12 to the right hand side. It becomes a positive, and therefore the value of my x is positive 8. So my coordinates for C will be 8 and 20. Let's go to the fourth part of the question, which says if the line BC equals to 5 units, so I have BC, that's 5 units, calculate the perimeter of triangle ABC. Before I'm able to calculate the perimeter of triangle ABC, I need to find all the sides AC and the side AB. To do that, I'm going to start by finding the distance AB. Using the distance formula, so I'm on my fourth question. The distance formula for AB is equal to, I have square root of y2 minus y1 all squared plus x2 minus x1 all squared. If I slot in the parameters, I have root of y2. If I tag my point, I have y2, that's 5, minus y1, 17, all squared, plus x2, that's 3, minus x1, 12, all squared. What I will have is, I have root of negative 12 all squared plus negative 9 all squared. That's equal to root of 144 plus 81. That's root of, I'm going to write it on the right hand side. That's root of 144 plus 81, that's 225. Therefore, the distance AB is equal to 15 units. So I have AB equals 15 units. Now to find AC, remember the perimeter of any shape is the total distance around the shape. So I've gotten the distance AB to be 15. BC has been given as 5 units. I need to find AC. Using the Pythagoras theorem, AC squared equals AB squared plus BC all squared. I have AC squared, that's the hypotenuse. The hypotenuse is the longest distance or the side facing your right angle. I have AB squared, that's 15 squared, plus BC squared, 5 squared. That's equal to 225 plus 25. AC squared equals 250. And to find AC, I need to find the square root of both sides. Therefore, my AC, remember from the question, we've been told to leave the answer in the simplest sort form. So that would be 5 root 10 units. Now I have my triangle as shown. I'm going to put it rough sketch here. The right angle triangle, I have that is C, B, and A. The dimensions are 15, 5, and 5 root 10. So therefore, perimeter of triangle ABC equals 5 units plus 15 units plus 5 root 10, which is 5 plus 15, 20 plus 5 root 10 units. Let's look at the second question. I have in the diagram below triangle ABC as vertices A 6 4, B minus 2 2, and C 6 minus 2 in the Cartesian plane. The angle of inclination of BC is theta. 1. Determine the coordinates of the midpoints of AC. 2. Determine the equation of the straight line BD. 3. Determine the equation of the straight line which is parallel to y plus 2x equals to 8 and which passes through the point A. 4. Determine the size of theta. And 5. Calculate the size of angle C. Starting with the first part of the question, I have 1. Determine the coordinates of the midpoint D of AC. The midpoint, somewhere, I'm going to put that as, I'm looking for the point D, XY. Using the midpoint formula, I have midpoint of AC equals x1 plus x2 using the midpoint formula over 2, and for y I have y1 plus y2 divided by 2. In this case it's my x1, y1, x2, y2. That will be 6 plus x2, 6 divided by 2, and for my y coordinate I have 4 plus minus 2 divided by 2. That will be 12 divided by 2, and 4 plus minus 2, that's 4 minus 2, 2 divided by 2. Therefore, the midpoint of AC, which is also your D coordinates, will be 12 divided by 2, 6, and 2 divided by 2, that's 1. The second part of the question says, determine the equation of the straight line BD. So I have a straight line cutting across B to D. The formula for finding the standard equation of a straight line is y equals to mx plus c. My y, my m, is the gradient of the line BD, so I'm going to start with that. The two variables I need to find are the gradient and c, point of intersection. Starting with the gradient, I have mbd equals my change in y divided by my change in x. I have that as x1, y1, x2, y2. I'm going to take out this point. So putting in the values, I have my y2, that's 2 minus y1, 1, divided by my x2, negative 2 minus x1, 6. That will be 2 minus 1, that's 1 over negative 8. So the gradient is minus 1 over 8. To find the point of intersection, if I rewrite my formula, that's y equals negative 1 over 8 x plus c. I'm going to pick one of the points to use. In this case, I'm going to pick the point D. Slotting that back into my formula, I have, note that if I pick the point B, I'm going to get the same values for C, but I'm using point D for this illustration. So my y is 1 minus 1 over 8, and my x is 6 plus c. So, making c the subject of formula, I have c equals 1 plus, I'm going to take my negative 6 over 8 to the other side. That will be 1 plus 6 over 8. And if I solve that, that's 1 plus 3 over 4. Changing that to an improper fraction, that will be 7/4. Now putting this value back into my equation, remember my equation is y equals mx plus c. I'm going to have that as y equals my gradient, that's negative 1/8 x plus c. C is 7/4. That's the equation of the line MBD. Let's look at the third part of the question that says, determine the equation of the straight line which is parallel to y plus 2x equals to 8 and passes through the point A. Because we've been told that the line or the straight line is parallel to the y plus 2x equals to 8, I'm going to start by rewriting that in standard form. So that will be y equal minus 2x plus 8. And because the line is parallel to this line, they're going to have the same gradients. So if you have two lines parallel to each other, the gradients are the same. So my m will be -2. The next point says, I'm going to rewrite the equation is y equals -2x plus c. That's the equation of the new line. It passes through the point A, and the point A in this case is 6 and 4. So I'm going to slot in those values. I have 4 to be y equals to -2, my x is 6, plus my c. I have 4 equals -12 plus c, and taking -12 to the other side, I have that as c equals 4 plus 12, equals 16. So therefore, the equation of that line will be y equals -2x plus 16. For the fourth part of the question, we have to determine the size of theta. To find the size of theta, we're going to start by writing the formula that states that the angle of inclination is equal to the gradient. So we have the tan of theta equals to the gradient of the line BC. We're able to calculate the gradient of the line BC. I'm going to do that shortly. So I have MBC. I'm going to take out the third part of the questions to have more space. Equals the change in y over change in x. BC. So I have that as x1, y1, x2, y2. Now y2 is -2 minus y1, 2 divided by x2, 6 minus x1 minus 2. That will be -4 divided by 6 minus 2, that's 6 plus 2. That will give us 8. Therefore, the gradient of the line BC is equal to -1/2. I divided both terms by 4, and I have 1/2. Therefore, going back to our tan theta, I have tan theta equals to -1/2. To find theta, our reference angle will be arctan of 1/2 will be 26.56, and this will be our reference angle. If I go back to my quadrant, I'm going to draw it here. I have my cast diagram, CAST, such that the point where I have tan theta to have a negative value will be point where it's sine only and where it is cos only. Also, note that if you look at the angle of theta as shown is an obtuse angle. To have an obtuse angle, I'm only going to have it in the segment. And in this segment, I have that as 180 degrees minus theta. I have this as theta. I have this as 180 plus theta. I have 360 minus theta. So using that value, I have therefore our angle theta will be 180 degrees because we are using this quadrant, minus a reference angle 26.56 degrees, and theta is equal to 153.4 to 1 decimal place degrees. Remember, our theta is an obtuse angle. Let's look at the last part of the question that says, hence calculate the size of angle C. To calculate angle C, I start with showing that the line AC is perpendicular to the x-axis. So I have a right angle as shown. Likewise, we have the straight line BC such that the angle theta is an external angle to the triangle as shown, and using the external angle of a triangle equals to the opposite interior angle, I have 150 degrees of 153.4 degrees, 0.4 degree, that's theta, equals 90 degrees plus the angle at C. Therefore, the rules is the external angle of a triangle equals to sum of the opposite interior angles. So therefore, angle C is equal to 153.4 degrees minus 90 degree, and the value of angle C will be 63.4 degrees. Thanks for watching. Bye.